Good day. Welcome to session 310, Jamf School and the API. Why? My name is Larry Stiegel. I'm a sales engineer here with Jamf on the education team. And in today's presentation, we will be joined by Shane Brown, who's a sales engineer, Patrick Bilkovic, who is our senior technical support engineer for Jamf School, and Andrew Perkle, one of our most accomplished test engineers on the Jamf School product. So the Jamf School and the API, why are we here? Well, our presentation agenda today is we're going to first of all talk about what is the API, tools for the API, how the API and the service desk work together, and finally, if you build it, they will succeed. So, beginning on our presentation, I started doing some research and I was trying to find out what is an API and how's the best way to summarize it. And I came across this from Peter Gazaroff. Before I learned software development, the API sounded like kind of a beer. Today I use the term so often that I've actually tried to order an API at a bar. The bartender's response was to throw me a 404, resource not found. So really, what is an API? It's an application program interface. It's a set of routines and tools for building software applications. Basically, it specifies how software components should interact. And finally, APIs are used when programming graphical user interface components or GUI components. But for our purposes, simply put, the API is a set of dedicated URLs that are going to basically return back just pure data. It improves performance by stripping out the unimportant information. More than anything else, what is the API as it relates to Jamf School? It's just the facts, nothing more and nothing less. Now, I can still remember how my MDM used to make me smile. And I knew if I had my chance, I could make those iPads dance, and maybe admin would be happy, at least for a while. But asset tags made me shiver with 14,000 updates that I needed to deliver. Bad news in Google Chrome. Maybe it's time I go home. I can't remember if I cried, since it takes forever and my brain is fried. Something touched me deep inside the day the web UI died. So why are we looking at the API in Jamf School? Well, we need to ask ourselves, what are those things that we do on a day-to-day basis, and how can we make them faster and more efficient? Well, first we need to find our information or our documentation for the API. And your documentation is actually located on your Jamf School website. If you just simply go to your instance.jamfcloud.com/API/docs, you can find out all of the information about the API, what information it can extract, and how to get it. Now, what does an API response look like? Well, I went ahead and decided, I went into my web browser and I pulled back information from the API on devices. This is what it looks like. Now, the important thing to remember is I only had 7 test devices in my Jamf School instance. So a lot of important information is given out extremely fast. I don't have to worry about pictures to render, HTML code. It's all text. The same information when I'm looking at the standard response from the Jamf School interface looks like this. So we strip everything down. The API gets you just those facts, just that important information. So how do you access the API? Well, basically, you'll go into your Jamf School instance and you'll go to your organization. And then once you click on Organization, there's a button called Settings, and then you'll see a button called API. Now, basically, you have to decide what you want to use and how you want to do it within the API. You can assign different permissions based on the API key. There are two pieces to the puzzle. The first is to create your key. That's going to unlock the resources for API. And you have 4 different choices that you can make and combine them. You can read information, you can add information, you can edit information, and you can delete information. So the key is, pardon the pun, determine what you want to do or what you want that individual to do. You set those permissions and you create a key. You can actually have multiple API keys on your Jamf School instance. Now, the second part of the puzzle is your network ID, or the account that you'll use when you're using and making calls into the API. So the most important question is, how do I find my network ID? Well, you'll go to your devices, and then once you click on that button, you'll look at Enroll Devices, and then you will see On-Device Enrollment and look under the area for iOS and macOS. And that's where you'll find your network key. So the key, or the network ID. So the most important thing is those two work together. The network ID identifies your Jamf School instance. Your API key determines your set of permissions or privileges. And now what I'd like to do is hand off our presentation to Shane Brown, and Shane's going to show you some tools that let us look at the information in a little better format than what I showed you. Shane?
Thank you, Larry. Hi, everyone. I'm Shane, a sales engineer with Jamf, and today I'm going to be talking about Postman. Postman is a tool that I use to help test and keep organized, especially when I'm just starting to work with an API. You can check out postman.com for more information. Everything that I use it for, and we'll talk about today, is available in their free tier, but they do provide additional options with paid tiers as well. Before we begin, a quick housekeeping note. The Jamf School API documentation is being updated, but currently, when you view the documentation, the URL examples are outdated. You'll want to use the structure shown here under New by beginning all API calls with yourinstance.jamfcloud.com/API. In Postman, you can create a collection of requests. This helps to stay organized and allows you to easily save a request so you can use it later with the click of a button. When you create a collection, you can save an authorization type or variables that will then be used by all requests within that collection. Here, we use your Jamf School network ID and API key for the username and password, respectively. Next, you'll add requests to your collection. You can swap between different types like get, put, post, and delete. Then, within the request, you'll add the URL. Once you're done, click Send to get the results of the request. Here, we can see the results or the output body of the request. Postman will automatically display the results in a clean, organized way. You can also toggle between the raw data or the pretty version, which is much easier to read. Additionally, you can choose the format type. However, with Jamf School, this is going to default to JSON. When a request creates or updates an object in Jamf School, it requires additional data. In this example, we are assigning the device to a new owner. To do this, you need to change the request type to put from get. With this put request, Jamf School requires the UDID of the associated device, which we supply in the corresponding value field. If we take a quick look at the Jamf School documentation for the request, you will also find parameters that the request will accept. For this example, we need to provide the ID of the user the device will be assigned to. You can find the user ID from the API, or it's contained within the Jamf School URL. When you're on the object in a web browser, In this example, the user ID we want to assign to the device is 65. Back in Postman, you specify that we want to assign the device to user 65 by adding JSON to the body of the request. Once you're finished adding the variable values and your JSON body to the request, click Send. You'll simply get a 200 device saved response if it's successful. Finally, in my opinion, one of the best features of Postman is that once you get your results built or your requests built, you can easily copy them into a script. Postman allows you to copy your API request in a number of different syntaxes, including curl, Python, and many more. To get to this feature, simply click the code button on the right-hand side of your request, and then select the language of your choosing. You can then copy and paste the snippet into a script, like some of the examples we will see in a few minutes. Thank you. And now, Patrick will walk us through API with the service desk.
Hello, my name is Patrick Bilkovic, and I am a senior technical support engineer with Jamf School. Today, we will be having a short discussion of API and the service desk. We'll be going over why API integration can have benefits, and a couple of common support requests that can be resolved by taking advantage of the API as opposed to a support ticket. First and foremost is why API, and the answer can be broken down to one simple sentence: granting functionality with limited risk. Especially when you're working with mid to large size school districts, you can have multiple admins in your MDM instance to help with that workload. The downside of that is the more hands in the cookie jar, the more likely the cookie jar is going to break. Things like making unapproved changes to device profiles, making devices or apps move between locations, or even a possible critical error that can cause the need for a full device fleet redeployment. The API can help solve this by allowing a system admin to create tech roles in the MDM with limited permissions, but then use the API to allow for some extra functionality. Now, I will cover a couple of common support requests that we see in the support realm of Jamf School that can be solved with an API as opposed to needing to open a support ticket. Common one is techs need to wipe a large amount of iPads, but as the system admin, this isn't something you want them to normally be able to do on an MDM-wide scale. A possible error with doing that could cause a full wipe of your entire deployment and cause them all need to be re-enrolled, which when you're talking about thousands of devices can be time consuming and catastrophic. What you can do is use the API to be able to identify a device group that those devices are a member of, and then send the wipe command to just those devices in that group. That way, you're removing a lot of that risk, which is why we call it using the scalpel as opposed to the nuke. Another good example is that remote learning has become a required tool for education in 2020. Using remote video teleconference software has also greatly helped teachers and students stay in contact to help ease this situation that we all find ourselves in with some familiar voices and faces. The only downside is that you can find yourself interacting with possibly K through 2 students or students that require special custom attention in their learning environments. So when trying to make those video calls, you need to make sure those meeting invites are being sent to the correct users and the call can be effortlessly answered. So, to show us the possible API-driven option for this scenario, allow me to introduce Jamf test engineer, Mr. Andrew Perk.
Hi, everybody. Thanks, Patrick. I'm Andrew, and I'll be talking about using the app in day-to-day applications. First, we'll go over using Python with the API. I use Visual Studio Code with a Python extension for building and running scripts. Python is my preferred language for APIs since it includes built-in modules for HTTP requests and JSON. Bash works as well, and curl is great for HTTP requests, but it does not include a utility to parse JSON. Since the Jamf School API only returns JSON, this makes the process of processing the data more complicated. Python is great for automating simple tasks that would require repeatedly running through the same steps. So, for example, there may be instances where we want to quickly get a list of email addresses for all students and teachers in a class for mass emails or to start a FaceTime call. So, what are the steps? First, we'll find the required endpoints to list the classes and get the details of a particular class. Then, we'll send the request and parse the JSON response from those endpoints to get the required information. Finally, we'll format output in a way that can be used in another program. Finding the required endpoints. This is where Postman comes in handy. By testing the request, it is easy to find what information is available from any given endpoint. The class's endpoint will return a list of classes and their associated UDIDs. This is required since the UDID is not a user-friendly value, so it'd be difficult to enter in a script or from memory. The class's UDID endpoint will return the details of the class, which includes the emails of the students and teachers. Next, we'll look at sending the request and parsing the JSON at a code level. We'll only look at a few sections of the script, but the full script is available as a gist on GitHub, and a link will be provided in the resources page I'll share later. Using the request module, all we need to do is provide basic arguments as seen on line 20. The first argument uses a variable for the base URL and adds the class's endpoint for the headers it uses as a dict from line 17 that sets the version. This is required since the API by default will use version 1, but the endpoint being used is version 3. Authentication is handled by the auth parameter. If we weren't using Python's built-in module, we would have to convert the network ID and API key to base 64, then pass it as a header. The request module handles that for us automatically, much like Postman does. Once the request is sent, the JSON module provides a method to load the response into a dictionary, as seen on line 23. Then, a new dictionary is created to hold each class name and its associated UUID, as looked up from the dictionary, parsed from the JSON, and each class's name is printed to the console. It then prompts the user to choose one of the classes. For brevity, we've skipped a few lines where the second request is sent using the UUID of the class, looked up based on the previously created dictionary from the input that the user entered. But the same principles apply as the original request. The response from the new request is also loaded into a dictionary using the JSON module. The script then loops over all the student and teacher emails in the response and appends them into a list on lines 60 through 63. Finally, that list is joined with a comma as a separator. As seen in the terminal output, this gives us a line of comma-separated values, which most programs will know how to read. Finally, those values can be used in other programs. Here they are shown pasted into FaceTime, where a call can be initiated to contact an entire class. Next, we'll look at a high-level overview of using Swift apps with the API. Since these are more complex, we won't get into technical details, but the full GitHub project will be provided in the resource link. So, why would we build an app? It could provide a simple interface to perform management tasks directly from an iOS device without needing to open the Jamf School webpage. We could deploy apps to devices to let users manage their own device. This might include changing users in Jamf School, updating asset tags, or wiping the device directly from the device itself. We might also empower administrators that aren't familiar with scripts to run actions themselves. So in the next slide, I'll show a video of an app interfacing with the API. Then we'll go over what is happening afterwards. All right, so what is happening? 1, the login is accepted or rejected based on the network ID and API key. The password is hidden automatically by QuickTime during the recording, but it was entered. It's worth noting a read-only key could look up the device, but not run the actions. 2, the camera is used to get data from a QR code, which is then used to filter the devices. A barcode could be used as well. 3, API requests are used to update the notes for a device record, which changes the values in the notes, which the app parses to tell if the device has a status of checked in or checked out. If the wipe command is used, it will send a request to wipe the chosen device. The app actually only uses a few endpoints. The devices endpoint to get devices, which is also used to check for a valid network ID and API key. The device's UDID endpoint to update notes, and the device's UDID wipe endpoint to send the wipe command. The rest is done using logic within the app. Managed app configurations could also be used to automatically provide the network ID and API key, removing the need to log in and enter a long API key manually. There are other apps that use the API as well. For example, the app Numerics, built by Synapse, currently uses the API to provide users with a dashboard integrated with Jamf School. This link will take you to a page with links to several great resources to use Python and Swift, as well as GitHub pages with the source code for the demoed projects. Now, I'll kick it back to Larry for a few final notes.
Thanks, Andrew. I appreciate it. And what a great job. Tremendous amount of information. So one more thing. More than anything else, we've talked a lot about the API, but I also wanted to give you a resource you could walk away with today. A lot of people are aware of this, but let's touch base very quickly. And that is Placeholders and Jamf School. Placeholders allow us the ability to update information. The way we access our placeholders is we go into devices, and there is a placeholder that you can actually utilize, a CSV import. You can import from any source. Optionally, you can choose to overwrite properties for existing devices. You will be required to supply the serial number of the device and an identification field. That identification field is only used during the process of assigning information through a placeholder. So you might use something if you had a series of iPad 01, iPad 02, iPad 03. But the information that you can update or set with placeholders include asset tags, assignment to a user, assigned to a member of a static group or groups, the name of the device, and the device's location. Placeholders are properties that can be also, as I stated earlier, applied to already enrolled devices. But be careful, you will replace current data. And with all things, test, test, test. And then when you're positive everything works perfectly, test one more time. So we've taken this little journey on the API. I want to leave you with a kind of an ending. So take a moment and say, today we were on our own and moss grows fat on a rolling stone. but that's not how it used to be. We learned about things that will make your life go right. This may allow you to sleep through the night. Maybe your spouse and you will not have to fight since the API has come to light. Thank you for listening, and please provide us feedback by completing the survey using the widget below. We will be monitoring your questions and providing you answers as complete as possible. Enjoy the rest of your virtual conference, and thank you.